7-3, day one pre-lesson. Quick review, a lot of stuff. This unit, 7-3, everything you've learned in unit 7 is just going to collide into one math problem. Good news, you've seen this stuff before. Bad news, it's all coming together. So here we go. Let's review standard position, which is typically given to you in this book as theta. They can use any symbol for this. Terminal side, we'll talk about that. Creating right triangles. What the heck is your reference angle? Why is that important? What is SOHCAHTOA? How does this relate to all of this? So we're getting at the heart of trig now. So first of all, standard position simply means always, always, always start with your spinner right there. Now, if I spin it, whatever, let's just say, I don't know, let's go 145 degrees. So what does that mean? Well, there's a little invisible plus there, which means up. So I'm going to go up 90. And I got to be careful here. So that's 55 more, which is approximately right there. And then I'd stop. 55 degrees. That little piece of information is important. Now let's talk about the terminal side. It's going to be my hypotenuse. What do you mean hypotenuse? Well, I'm going to create a triangle. Remember the golden rule? Don't you ever, ever, ever come back to the y-axis to create the right triangle. You always come back to the x-axis. Now this is my hypotenuse, which we've said is always, always, always positive. Here's my right angle. Where's my reference angle? It is always sandwiched between the x-axis and the hypotenuse. It's never this guy up here. Always this, which makes this my opposite side, makes this my adjacent side, and we know what our hypotenuse is. And then we can figure out SOHCAHTOA. So if we had to figure out sine of our reference angle, we'd go opposite over hypotenuse. If we wanted to find cosine of our reference angle, we go adjacent over our hypotenuse, and on and on and on. So there's your little quick reminder. Now we're going to apply some of this. So a quick heads up, a little reminder of all four quadrants. Remember, we're going to be creating our triangles by spinning the spinner. Now there's four things that can happen. The spinner can end in the first quadrant. And this would be my x, which is positive because I go to the right. My y would be positive because I'm going up. And that means this is a positive x, positive y. I just gave you an example. There's my x, there's my y, 4, 8. So positive, positive in the first quadrant. And we know that our hypotenuse is always positive. I'll throw that in for free. What if my spinner ended up over here somewhere? Well, I'd create my triangle by coming to my x. So my x would be negative, left. My y would be positive, up. And that would take me to that spot. Here's a concrete example. -6, 8. How about quadrant 3? Well, if my spinner ended up somewhere like here, I might as well extend it. And then I'll create my right triangle. How? By coming to the y? No, never. Go to the x. And so what do we got? Well, -x, -y to get to this point. Here's a generic example. -6, -8. Both my x and my y's are negative. And my hypotenuse is positive, hypotenuse is positive. And then what if my spinner, well, let's say my spinner goes down, or let's say it goes all the way around, but regardless, it ends up in my fourth quadrant. I create my right triangle by always going to the x. So my x is positive, my y this time would be negative. My hypotenuse is always positive, keep that in mind. Here's a concrete example for all the things that happen in quadrant 4. A random point, 7, -8. My x is positive, y is negative. Now that's a lot of information, but it's kind of simple too. Just remember what quadrant you're in. It's very important with this stuff. Last problem of your pre-lesson. This is actually a problem, okay? So it says, what is the sine and cosine of 2 pi over 3? Notice that's in radians. So to help our brain think, Maybe you want to go, hey, pi over 3, we know it's 60, I hope. 2 times 60 is 120 degrees. So let's go ahead and get started. I'm going to throw a little twist at you now, so I hope you're really paying attention. So we start here in standard position. There's an invisible plus there, so we know to go up. And I've been begging you guys to be super accurate with your drawings. So continue doing so. 90 plus 30, don't just randomly stop over here. 30 is about like that. So there's where my spinner would stop. Now, to just eliminate some confusion, the book always uses what's called a unit circle. And when you see that, they're telling you let the spinner always equals 1 unit. So we know this is 1. Now, I want to help you guys understand something. So I'm going to draw a triangle that's a little different that you're used to. But now look at, if this is 90 and this is 30, the very important reference angle is always right here, which has to be 60. So that little 30 just goes away. I don't care about it anymore, because when I create my triangle, it's going to come down here. This is 90, this is 30. Now what I've been doing so far is I've been saying like this, hey, if they don't give us sides, take it easy on yourself. That's got to be a 1, that's twice, this is the square root of 3. Now what they're doing essentially is they're cutting this in half, so this is a 1, and so that means I got to cut this in half, so it's a half. Now notice, the rule's still the same. If I multiply this by 2, I get 2. If I multiply this by 2, I get 1. But then I got to multiply this by the square root of 3, so that would be the square root of 3 over 2. Now, back to the quadrants. We're in quadrant 2. What does that tell me? This x has to be negative, so I'm going left. This is positive, so I'm going up. So, with these 3 units in play, what is sine? Well, remember, sine is so sine, watch this now, of 2 pi over 3 equals, because that's my problem. You could also write sine of 120 degrees. So either way, what's the opposite side? The square root of 3 all over 2. Now, watch this. What's the hypotenuse? 1. What's anything divided by 1? Itself. So there's sine. Okay? Now what about cosine? Do that in red here. Cosine is chi. So I'm finding cosine of 120 degrees, and I know my adjacent side is negative 1/2. My hypotenuse is 1. Anything divided by 1 is just itself. So there's my answer for cosine. There's my answer for sine. So you're going to be getting quite a bit of that. Now I want to show you guys something. What if we stuck with these other units? This would be 1, 2, square root of 3, following our typical 30, 60, 90 rules. This is minus. So now watch this. Let's start with sine. Based on these dimensions, sine will be opposite over hypotenuse. It will be square root of 3 over 2. Done. How about cosine? Well, that'd be adjacent over hypotenuse, negative 1/2. Done. I prefer using these dimensions all the time. You're going to get the same information, but it's your call. All right, watch this second example problem video. It's going to help you out a lot.